Okay, this is video 3, the final one of this packet, solving quadratics by graphing. We're going to look at a couple different things here. But you'll notice that we're still talking about the fact that we have a standard form equation as a function. We're going to talk about the x-intercepts, or the roots, okay? The x-intercept is when y equals 0. Okay, so we're going to talk about solving algebraically and then check by graphing. Okay, so let's solve this one to get x by itself. So if I have 1/2 of x squared equals 8, I want x squared by itself. So I could divide both sides by 1/2. Dividing by 1/2 is the same as multiplying by 2, is it not? Just like the same as dividing by 2 is the same as multiplying by 1/2. They're reciprocals of each other. So when I do that, I get x squared equals, what's 8 times 2? 16. The inverse of squaring a number is taking the square root of that number. So x will equal, if you remember back to Mr. Nash, and he's the one who talked about this, we take 16 out of the square roots, we have a good and bad twin. So we get positive and negative 4. Because negative 4 times negative 4 is 16, and positive 4 times positive 4 is 16. So our roots are positive and negative 4, which means when I graph this, my x-intercepts are positive and negative 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay? That will tell us that we have those x-intercepts. Now, if we wanted to find the vertex, we could take this and we want it to equal 0. So now I have 1/2 x squared equals 8. How do I get 8 over here? I subtract 8, right? Which means I would end up with 1/2 x squared minus 8 equals 0. Which means my vertex is at negative 8. Okay? You can always check it with a graph if you want to make sure. We'll try another one here, and this time we'll make a t-chart with it and see if it comes up the same way. I want to get x squared by itself. Okay? Multiply by 3. Multiply by 3. X squared equals 36. Square root everything. So x equals, hopefully you're saying positive and negative 6. Okay? So positive 6, 1, 2, 3, 4, 5, 6. Negative 6, 1, 2, 3, 4, 5, 6. Okay, now let's make a chart. And let's see if we can figure out what our vertex is going to be. Okay? So we can 1/3 x squared minus 12 equals 0. Okay? Well, let's just plug some numbers in. What if I get number 1? That's what I said I was going to do. 1 squared, so 1/3. 1/3 doesn't equal 12. We're not going to be able to check this. Then we check by graphing. Okay? So let's look at negative 12. So it's just going to be a wider. Notice how the fractions are making it wider and the whole numbers will make it more narrow. All right, let's look at this one. Let's take our solution here. Okay? Let's go back and look at, we're going to go in our next lesson about factoring to find roots, but let's look at our vertex. Let's do this one with our vertex. I guess we could go back here and do it with our vertex, which is the opposite of b all over 2a. That's 0. Okay? So 0, negative 12 is what we would end up with. Okay, so let's do this here. The opposite of b over 2a. The opposite of b is negative 6 over 2 times 1. So negative 6 over 2, which is negative 3. So x is negative 3. So we substitute that in. Negative 3 squared plus 6 times negative 3 plus 8. This needed to come over here, sorry. I needed to tell you to put it in standard form. I skipped that, my bad. So 9 minus 18 plus 8. Okay, negative 9 plus 8, negative 1. So the vertex is negative 3, negative 1. 1, 2, 3, 1. Okay. Now, I can substitute in and figure out values for x and y. If x is 0, y is 8. Okay? If x is positive 3, I would have 9 plus 18 plus 8. Something wrong here? No. Oh no, because that's our vertex. My bad. What if I do, sorry, negative 6? So negative 6 squared plus 6 times negative 6, negative 3, plus 8. So 36 minus 36 plus 8. That's going to also be 8. Okay? So 0, 1, 2, 3, 4, 5, 6, 7, 8. And negative 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. And there's my graph. Okay? So you can get, the one thing I want us to make sure we're getting here, these are just like what we did, is being able to sketch the x-intercepts for the roots. Now, when is it possible that we wouldn't have any roots? It would be possible when we have a problem like this. X squared plus 25 equals 0. Remember, it's our goal to get x squared by itself. So we would subtract 25 from both sides to do that. So we have x squared equals negative 25. I'm going to take the square root of this. Can I square a number and get a negative product? No. So when you have a negative number under the radical, you're not going to have any solutions for that. There will be no solution. When you have a positive number under the radical, you will have 2 solutions. Page 566 in your textbook will talk about that. And when you have the vertex at the origin, you will only have 1 solution.